So let's take a look at example 5 here and start to see how we can use this product rule where we have three functions being multiplied together. Notice here, f of x consists of an x squared, which I'll call our blue part, an e to the x, which I'll call our red part, and a square root of x that I'll call the green part. So based on what we had just seen in the previous video, we know that if I wanted to calculate f prime, I just have to go ahead and calculate the derivative of one of these pieces at a time while keeping the other pieces the same. So let's just start by saying maybe I'll begin by taking the derivative of the blue stuff and leave the other stuff completely alone. Then I'll just slowly shift. Now I'll take the derivative of the e to the x stuff and I'll leave all the other stuff alone. And then I'll finally leave the first two pieces alone and take the derivative of the square root of x. Done. All right, so if I can crunch out all these things, I'm good to go. Well, what's the derivative of x squared? Well, I can use the power rule for that and just end up with 2x. So I get 2x e to the x square root x. Over here, the derivative of e to the x needs to be calculated, but that's the easiest derivative rule of all time because that's just e to the x again. And over here, I have square root x. Remember, though, that can be easier to take the derivative of if I think about it in the form of x to the 1/2. So I'm going to have x squared e to the x and then 1/2 x to the negative 1/2. Now if I wanted to, I could go ahead and actually do a little bit more simplification here. What you might notice is that, wait a minute, I actually have x's that can be kind of multiplied together here. If I imagine each of these radicals as a 1/2 power, I could start to combine some of the powers of x. So here, since I have x to the first and an x to the 1/2, I could write this as x to the 1/2, or 3/2. In the middle here, since I have x to the second power and x to the half, I could write this as x to the 2/2, or 5/2 power. And over here, since I have x to the 2 and an x to the negative 1/2, I could write this as an x to the 1.5, or again, 3/2. Now, if I was to do this, I could even simplify further. So notice here that I have some e to the x's that here are in common, so I could like pull that out. That would give me 2x to the 3/2 plus an x to the 5/2 plus a half x to the 3/2. And actually these terms at the front and the back are actually also going to be like terms that could be added. And so I could see that I'm going to end up with 2.5 of these x to the 3/2. Or if I write that as a fraction, again, that's 5/2. So this work here is actually just completely optional. So all of these simplifications here, optional. I could have just stopped right here at this first line. That's still the derivative. But again, as we'll see in sections to come, sometimes simplifying is going to be very important when we want to start doing some things with our derivatives rather than just computing them. Now the reason that I showed this here is because I actually want to highlight one other important process, or thought process, I guess, that we could use here to tackle this question. We thought about this question as a product of three functions, but did we have to? I'm going to go down here and just kind of write a big or, and underneath it I'll say that we should be able to see that f of x could actually be rewritten, if I think about that square root x as x to the 1/2, as x to the 5/2 times e to the x. I could have like simplified right from the beginning. And if that's the case, then I would have only had two functions being multiplied together. And if I only had two functions being multiplied together, then when I take the derivative of those, I would really only have to focus on using the regular product rule and not a product rule for like three pieces. So I could start by leaving my x to the 5th alone and taking the derivative of e to the x, which is just e to the x. I could then do 5/2 x to the 3/2. I just did the power rule there. and then leave the e to the x alone. Since there's an e to the x in common, I can go ahead and factor it out, and I'd be left with x to the 5 halves plus 5 halves x to the 3 halves. And of course, what do you notice about the answer that I got up here and the answer that I got down there? They're the same. But of course, it may seem like this second approach actually took less work to get there. Again, it's really important to remember that simplifying before you take a derivative can really save you a lot of time. And so I very much encourage you to think about if there are ways to simplify before you just jump in and start calculating a derivative. Hopefully this example demonstrated that to you, as well as how to tackle a question by looking at it as a product of three different functions.